Hello friends, in this session I am going to tell about the implementation of CNN of IMDb data in Google CoLab using Python. IMDb data is a text sequence data which consists of the sentiments of the many people taken from the Twitter, right? So we will just go to again Google CoLab as I have shown in your previous session. We will go to the plus code. That means we are running to the new Python code. We will go to file and then we will say new Python 3 notebook. So this is my new Python environment where we can write on our own the program itself. Since it is not possible here to write each and every line of the program, so I have written the program in Word document. I will just copy it and paste it here and run it, and I will tell you that what each and every line means, right? So this is my code window. What I will go to the Word document. Here I will just copy it and then I will just run here in Google CoLab, right? Now I will describe that what is the actual each and every line means. Now here from here we have seen that from keras.database directly you are getting that import IMDb. IMDb is your default database in Keras only. So directly we have written that keras.datasets, you just import that database, that is your IMDb, right? From keras.preprocessing import sequence. Since it is a sequential data, so we have to do some processing of the sequences. So that's why we have import the sequence also. It is also there in keras.preprocessing. After that, we have taken that max features equal to 10,000, maximum length is your 500, and we have just, when we will run this program, it will just show you that loading data. That means it is loading the data. Now, when we will load the data with this command, that is your xtrain, ytrain, xtest, ytest equal to imdb.load underscore data, and we are telling that numwords equal to max features, you may get somewhere, you may get some problem, that is, you can get that you have to allow pickle equal to true. Otherwise, it will not be able to load the data. So the first program, what I have done here, 3 lines, that is to allow pickle is equal to true, right? So import numpy as your np, and we are taking that np load equal to np load old, and these old values we are taking that parameter allow pickle should be equal to true. Otherwise, in some version directly you can get the allow pickle equal to true. So that's why this 3 lines and this 4th line we have done. Otherwise, if you get somewhere that this allow pickle is directly, if you give this line, then sometimes you may get directly the values also. You may not give this allow pickle equal to true, because in some versions automatically allow pickle is equal to true, right? So you don't have to do again and again. So we have done this, and we are printing that train sequence, we are printing the test sequence, we are printing that pad sequence. This sequence padding is necessary because if you don't pad, then the values of the number of rows and the number of columns will not be equal, right? Now, if you are saying that xtrain equal to sequence dot pad sequence, what you are padding? You are padding xtrain and max len equal to max underscore len, right? Maximum length. What you are taking in max len, that is your 500. That means since it is a sequential value, that means only you will get the row wise value, right? For example, there are 2500 sequences, but in column wise you will not get any value. So we have to padded those values in the column wise. So we are taking that you have to pad how many values? You have to pad the 500 values. That's why we are taking that max len, right? Similarly, in the test also we are adding the sequences or padding the sequences. We are taking that x underscore test, and after that max len equal to max underscore len, right? So when you will be getting this, shape, that is, for example, if you are taking X train, right, dot shape, if you are giving this command and if you are running, then finally you will be getting that what you will get in text train dot shape, right? We will just see to it. It is running, so it will take some time because it is importing NumPy also and it is importing the database also, and after that it will pad the values and it will show the values. You can just see that it is downloading the data, right? And finally it is showing that what is the shape of X train, because we have 25,000 sequences in the row wise and 500 columns you have padded into it. So we are getting the row values is your 25,000 and the column values is your 500. That is the actually function of the pad sequences, right? And in sequential data, maximum times you have to pad these sequences, otherwise you will not get the values in column and the row wise, right? So this is your first point, first code we have written, that we have done the the importing of the database, and also we have done the padding of the sequence into the X train value and the X test value, right? Second code window again we have opened, and now we will go to again Word document. Now second commands we will just copy it and I will show you that what do you mean by this. So we are again pasting this command. Now what we are doing, very simple way, we are doing that from keras.models import sequential. In the demo version also I have shown you that how to build the sequential model, right? So here you can do in very easy way, that from keras.models directly you can do import sequential. From keras you can import layers, that also we have done in the demo version. From optimizers you can import RMS prop, that also we have done. We have done in a different way, but in the similar command you can run here also. So what we are doing, that model.sequential, and after that now we are adding the layers, because we have to, first of all we have given the embedding layer, second time we have given the convolution layer, third we have given the max pooling layer, and this you can give more than one time, because in the hidden layer you can get the number of times of this convolution ReLU layer and is your max pooling layer. So first of all we have added the embedding layer. What we are doing, that whatever input sequences are there, that we are converting into the 128 values. That means output of the embedding layer will be 128 values. From this 128 we are getting the 32 output, because in the next convolution layer we have given 32. So here one command we have used, that is your conv1d. For image purposes we have to use the conv2d, because image is your two-dimensional signal. Since we are working with the sequential values, so we are using here conv1d. Now this 32 is the number of features it will output, and this 7 is your filter size. As I have shown in the theoretical video, in that video we have seen that 3x3 filter size, that means 9 features, right? Here we are giving the 7 features. Since it is a sequential, we cannot get 7 cross 7, right? We can get total only 7 features. So 3 features will be very less. So here you can take 7, you can take 9, you can take 11. Like this you can take the values, you can change the values. And here we are taking activation equal to ReLU. Finally, what we are doing, that convolution we have done, ReLU also we have done. Now we are giving the max pooling 1D, right? Max pooling 1D and 5. That means the filter size is your, pooling layer size is your 5, right? And similarly we can continue the same thing, that is your conv1D, again 32 we are giving, 7 activation equal to ReLU, and finally we are giving the global max pooling ID. That means if you are using the 3 max pooling, then what will be the maximum of that max pooling layer? For example, first of all, you are using the max pooling is your 5, next one is you are using 7, third max pooling you are using 11, then last you can give, that is global max pooling. That means then in global max pooling 1D, you can take that among these 3 max pooling IDs, which will be the maximum number, that is 11. So finally it will add layers with the max pooling 1D as your 11. Finally, you are giving the dense one, that is your output is your 1, and then you can give the model.summary and xtrain.shape. Now, if you run this program, then you can see the summary also, and it will be giving you some values, right? So what it is giving, that is your first of all max len, because we have taken the max len, that means 500 features we have taken, right? First of all, 500 features we have taken. Input shape is your max len, that is your 500. Out of 500, we have taken only the 128. That means it has been converted into the 128 because in embedding layer, we have given that 128. And input length is your max len is your 500. So from 500, we have converted into the 128, right? After that, in convolution 1D, we are getting 494. Wow, these values is coming 494. Basically in 494 it is coming like this, that is you have the 500 features and you are using the 7 filter size. That means 500 minus 7, that is your 493 plus 1, that will be 494. So that's why in case of convolution 1D, we are getting the 494 inputs. After that, because first of all you do the filtering, after that only you pass to the convolution layer. So these many features has been used in the convolution layer, and output is your 32, because as you have seen in the program also we have given the 32. In max pooling, we are getting again 98 and 32, and finally we are getting convolution 1D, that is your 92. That means 98 minus 7 plus 1, that is your 92, and again we are getting the output as 32. In global max pooling, we are getting output as your same, that is your 32 you will be getting, and finally in the output layer we are getting 1, that is your only one layer dense, only one neuron it will be output, and it will give us the value. So this is your final one, that is your that is output we are getting as your 1. And next is your third portion. Third portion we are getting, that is your model.compile and model.fit. Now we will see again copy, and then we'll go to Google Chrome, and then we'll say plus code, and the third paragraph code we will be pasting it, and here again we will run, because here we have given that model add, model sequence, and all these things we have done. Now we have to train that model, compile this model, and we have to fit this model, right? And same thing we have done here, that is your optimizer, we are using the RMS prop. Loss, here we are taking that binary cross entropy. In the last case, loss we had taken as your mean squared error. Here we are taking the loss equal to cross entropy, right? And we are fitting that model with the batch size is your 128, and here also validation data we are taking as your 0.2, that is 20% we have taken as your validation. So here it is taking, that is your epoch we have given, that is your epoch is equal to 10. So 10 times it will it will do the iteration. So after 10 times automatically it will close, and it will be, the model will be fit for your use. After that, the same you can do what we have done in the demo, that you can plot your loss function, you can plot your the metrics. Here we have taken metrics as your most probably accuracy. Here we have taken, yes, metrics as your accuracy, that is your ACC. So this accuracy you can plot as we have done in the demo version also. So same command as your PLT command. PLT you can take as your matplotlib, import matplotlib as PLT. After that, with PLT object you can plot your all this data, and you can see the loss function, you can see the error function, then after that you can see that you can predict also, and you can see the difference between the predicted values and the true values, and after that you can find out that what is your actual accuracy, and that you can do with the help of the number of epochs. You can increase the number of epochs and you can see the differences in that, right? So this is your actually that how the time series data can be implemented in CNN in Google CoLab. Same program, you can just copy it and paste it into the Jupyter notebook and you can run it and you will see the same values only it will show, right? Now what should be your assignment? Assignment will be that you can download any smart grid data and you can implement in this convolution neural network. That's why I have given the examples of time series data so that you can do on your own and you can implement it, and you will see that how the predicted values are different from the true values and how they are nearest to the true values, right? Depending on this, you can give the trial and error method and you can find out the final accuracy. That's all about the implementation of CNN using this time series data in Google CoLabs. Thank you.